Hello, my fellow YouTubers. This is Roy back again. This experiment I seem to think is one of the finer experiments. Let's go over the setup. You got your magnets all facing out north. You got your laminate core, iron core. We're using just one set of wires here for a primary. We're using this vibrator gap in relationship to the core. We have a 12 volt battery here that we are going to disconnect. So the 12 volt battery we're going to use, I'm going to do an experiment with it, but we're not going to use it right now. From there, we are coming out. One end goes to the negative side. This is the positive side. This side is the positive side. So that's the positive going in. And this other wire, the upper wire, is the negative going in. And then you got your closed circuit here to the relay spark gap, to the inductor, to the magnets. Let's go out here. And I hooked up a DC 12 volt motor. What the setup is here, it's got the solar panel. Now the whole premise here is the sun's down. It's down past the trees, you can see it there. It's a little cloudy, not that bright, and there's light out, but no sunlight. Now this right here is the voltage reflecting to what's appearing up here. And that's the two end of the wires coming from there, so there's nothing going on. And you got each end here. That's the positive side, it's the negative side of these wires. Now I'm coming out of the motor. The green is going to the positive side, and the white's coming up to the negative side. And also tapped into that would be the voltmeter, 0.6. Now on the back of the solar panel, I'm coming out on the positive and negative side, and the one side comes up and touches the negative side, and the other side comes up, that's black, touches the positive side. Didn't do that on purpose, but that is connected to this circuit, and this circuit right now is not getting any juice, but it's still connected. So I want you to think about this. This sling board, I'm calling it. Now remember, the outside is aluminum. Aluminum's touching the ground's touching the casing, and it's isolated from the rest of the relay. This relay is not being used other than the two terminals are acting like, two terminals, and they're carrying the wire across. Keep it away from Vinny. So right here we got nothing going on, and we got no motor turning, right? Let's go over here and let's see the relationship between the magnets and the Bedini to the iron core and through the copper wire and on out through the spark gap into the said carrier wires, transmitting wires to the motor. And all we're going to do is, there's nothing connected, there's no power here now. Let's just spin it. So it's spinning, and there's no spark that you can see. But somehow, the motor's turning. Look at the volts showing up over here. Now this is from the induction with the motor turning. This is from the induction of the magnets. And you can see it dropping. Motor's getting slower, the volts are going down. The motor is barely turning. The wheel turning very little. Now let's stop it. Let's give it a big spin and then go back. All right, big spin. Now we come back. We got good turnage on the motor. Volts wise, we're bouncing over here. And this is because of the induction in between the magnetic wheel and this part of the circuitry. All right, so let's pause there. What now? You know, this is going to stop and slow down. It's doing pretty good. It's just reacting to the core, and that change of field is pushing out the wire. It's running up through the wire over here, and we got a load on it. You can see the load still turning. You can see the volts and bearings just dropping down, and there's no sun, so nothing coming in from this end of the power source. So basically we're splitting the power source. Now this has become something different because it's not a power source right now. But this never happened to me before. Any other time I tried an experiment, not this extensive, but coming off and running a motor, it's always been that I'm putting power in. Now I'm not putting power in. Now we're talking the power that's in is the fact that I have to take and move this wheel, and that's the power it's taking. So let's step it up a little bit here, and what if we introduce power, 12-volt battery, into each leg here, so we're just tapping in. Everything else stays the same. So this 12-volt will come over here and shoot in this part of the circuit. And in this part of the circuit, this will be oscillating. This will be oscillating in two different ways. If you put the magnet in front of it, it oscillates to the resonancy of the coil. If you start to move and overcome the oscillation, it's like a twofold here. The make and break right there, because the way we'll call this the jackhammer is set up, the points, that it will resonate to the inductive field that is going on here. So from there, you're going to have a difference in frequency from this on the points versus this will be wide open. But the interesting thing is the 12 volts is coming over to here. But remember, we're tapping here. So this pulsation is still being tapped out in DC pulse from one end of, one end of the spark gap goes back into the coil. One end of the coil comes from the power source. So right here's the positive. Now the negative obviously comes around and goes to the other part of the spark gap. So you're creating a positive and a negative connection only through the gap, but going through the coil as well, with the induction in between the wheel and that part of the circuit stays going. And then we're going to walk over here and we'll take a look and see what's going on here. So let's go ahead and connect the positive side to here, and then the negative side to here. As soon as I touch it, we should hear that. I don't know what just happened. Something just blew up over here. What the heck? Oh, my motor fell off. And it broke. So when we connected them wires, I'm assuming it made the thing vibrate and rolled off. Interesting. Back over here you got oscillation, the resonance of the coil, the primary. Then let's go ahead and spin the wheel. Now you got the gap taken over. And now you can see that the wheel's picking up speed. And let me see what I can do here. I think I broke it. Well, I think when it fell, it broke. Let me grab another motor. Oh, hell, here's a big, I think it's a 24 volt. Let's give it a test run. There's the volts popping up on this side. I'd be surprised if this pops on. It's a 24 volt. Oh. It's turning. Well, I'll be damned. It's 24 volts. Probably run a little slower because it don't have the... Bye-bye, son. So we'll run the motor here. Well, I just picked up. Just picked up speed. Look at the volts showing up. 24 volt. It's a 24 volt motor. It's acting like it now. So somehow, on the back end here, it's taking care of business. What's going on the front end here? Wheel slowed down a little bit. It's still clicking. Let's stop it. Let's allow it to do its thing. So it's resonating, wheel's not turning. There's the bolts out here. Everything's falling apart one hand. All right, guys, we're gonna leave it there. To the oscillator, the solar oscillator. Let's disconnect the battery. Let's see what's going on with the motor. It shouldn't be moving at all. And it's too big to show. At least that other motor is showing it at low voltage, so you can see that it was. Let me give it a whirl, walk back over to it. There we go. I doubt it. Nada. Oh, we disconnected it accidentally. Hold on. Get it connected at least before I discount it. Well, and the beat goes on. You guys, peace out. No power, no battery, wheel. This is Vinny and I. Leave your comments.